think anyone who's ever done any sort of research, especially in psychology and the other behavioral sciences, knows that it can be tremendously rewarding and also tremendously frustrating. Sometimes the greatest frustrations come from trying to do different forms of statistical data analysis. Some of my own frustrations have come when I've tried to use those analyses or perform those analyses in the statistical programming language R. In an effort to overcome some of my own challenges with R and hopefully instruct you about how to use R, I'm starting this short video lecture series that I'm calling SeminaR, which will step through some basics of the R language, how to use it, and how to do some of the familiar statistical analyses that we do in my experimental methods PSYC 440-640 class. So hopefully you'll find it interesting. Today this is just an introduction, it's very brief, and will hopefully get you oriented to what R is and kind of roughly how it works. In future seminars I'll get into greater detail. So by way of an overview, what will we be covering today? Well, first I'll ask what is R and try and give you a brief description. I'll tell you how to get R, and at least a little bit on how to get started with R. So first of all, what is it? R is a language for statistical computing and graphing. It's actually an implementation of a different language called S, and it was created by researchers originally at the University of Auckland in New Zealand. Currently, R is developed and maintained and kind of curated by a large team of people called the Comprehensive R Archive Network, or CRAN. CRAN is the place where you would go if you wanted to get a copy of R or get a copy of the various packages that R uses. And this is, I guess, a little bit jumping ahead, but the way R works is there is a basic source code that gives you the basic functionality of R, which is usually grouped with some basic packages. Packages are just sets of code that can do specific things like particular types of analyses or particular types of graphing. Later on in your work with R, you may want to do something more exotic, a form of analyses which is new or unusual or not a lot of people do. The base package or the base configuration of R might not offer that functionality, but if you're lucky, and you often will be, someone else has written a package for it. So you want to do some form of time series analyses or Bayesian analyses or item analyses that don't easily work within basic R, you can download a package for it. I'm not a big computer person, but I've got a little bit of experience using Linux, and people who know much more about Linux than me might be more comfortable or familiar with this approach to computing, where you download a basic sort of configuration for a program and then you add in packages. That's something which those folks are probably a little bit more familiar with. People like me who more typically use Windows or occasionally Mac, this is a little bit of a different way of thinking about computing. Anyway, what is R? Or what are these packages I'm talking about? I guess I've already kind of said that. The packages are just programs that add functions to R, ways of manipulating data, doing tests, creating graphs, etc. And at the very end of this little mini lecture, I'll talk about getting one of the packages that you may want to get once you've got R. So how do you get R, or where do you get it? Well, like I said, it is available for free at the CRAN, which you can see the URL for right there, or if you just go to any search engine and type in CRAN or even just R, you'll very likely hit on that as one of your majors, as one of the first hits that comes up in your search, so it's very easy to find. As I guess I've already mentioned, it's free and it's very flexible and powerful, which kind of explains why R is becoming increasingly popular as a way of doing statistical data analyses, especially kind of as an alternative to expensive and in some ways clunky programs like SPSS, which a lot of folks in psychology are probably more familiar with. I'm certainly more familiar with. If you're taking a look at R, at the CRAN, and you see different versions of R, you'll notice that they have a sort of a naming convention that works like this. The major sort of revisions, minor revision, patched to the minor revision is kind of the way the names are set up. I'd encourage you to just get the most recent version, but technically, or at least for the purposes of this SeminaR series, you don't really need the most recent version. Any version will work. When you look for a version of R, you'll probably see some different options. Like for instance, if you're in Windows, you can download either a 32-bit version or a 64-bit version of the program. That 32-bit or 64-bit refers to the nature of your operating system. If you're running 64-bit Windows or 32-bit Windows, that probably, that's something you can check just by clicking around in the program menu or the start menu of your computer. It's not too hard to find that. When in doubt, I guess you could go for the 32-bit version, which would run on a 64-bit operating system. For the purposes of a lot of what we're going to do, it really doesn't matter that much. Either one would be fine. I'm running 64-bit Windows on my desktop computer here at work, so I just use the 64-bit version when I need to. So downloading R is pretty simple. You just download the base package or kind of configuration. It'll install itself pretty quickly. It'll ask you a couple questions. What about packages? These I've already mentioned. You can download these from CRAN, but you can also download them directly within R. So once you've opened up R, you have a kind of a limited command console with a command prompt and a short bar of menus up at the top. You can find packages within R, and you can just add the ones you need. For the most part, this is pretty simple. Just download and install, follow the default options, and you should be good to go with both R and some of the base packages that it already naturally comes bundled with, or additional packages if you want to install them. So just really quickly, let's get started with R. Like I mentioned already, the initial way you encounter R is through the console. This is kind of a simple user interface that has a command line. So if you're as old as me, you probably remember when a lot of computing was accomplished through command lines, like working with DOS or other operating systems before Windows. If you're younger, you maybe are unfamiliar with this way of operating a computer, unless maybe you're a Linux person. The command line interface is not that hard to use in R, and it certainly allows you to do things quickly once you're familiar with the syntax for the various commands that the different packages have. The console does have a limited set of menus, so it kind of works a little bit like a graphic user interface. There's some menus with some pull downs. The easiest one is, if you look around, you can find the menu for installing more packages, so that's easy. We're going to be taking a look at some of the graphic user interfaces that people have developed for R to make R easier to use in a future SeminaR lecture. This is just a graphic that I took from Andy Field and colleagues' book Discovering Statistics Using R, which is a version of his popular and I think familiar to most people Discovering Statistics with SPSS textbook. By the way, I'd highly recommend that as a nice introduction to R, especially if you're already familiar with his SPSS book or even his SAS book, because the R book kind of follows along roughly with the same set of examples and chapters that his SPSS book worked with. And so what you can see here is his little graphic giving you a kind of a sense of what the download and installed version of R looks like under Windows or under Mac. And you can see at the bottom there some images of what the console looks like. It is, of course, a graphic user interface in the sense that there's some menu options, but it's pretty simple. Okay, so when we're thinking about R, a lot of what we're going to be doing in it involves manipulating objects and functions. And I suppose if you're a computer programmer, you probably have a very precise understanding of the grammar involved in a lot of what I'm about to say. I'll probably make some mistakes, so I'll ask your forgiveness right now. In programming, generally, and especially in R, an object is just anything that the language creates. So in this case, an object is anything that's created by R. It could be a variable that you've created, like a variable which refers to a score that participants in your study have on a measure of neuroticism or alcohol consumption or whatever. It could be a collection of variables put together in a data frame, which is kind of like the familiar spreadsheet setup that we see in Excel or in SPSS, where columns are typically different variables and rows are different cases, often participants. An object could be a statistical model, so a particular regression equation that you create to predict one variable based on a set of other variables could itself be an object that you could then work with in some other capacity. Functions are anything that R does to create an object. So anytime you're manipulating data or running a test or doing almost anything, you're using a function. A function will create or will manipulate in some way an object. And the basic syntax of most commands, most things that you would type in to the command line in the console, looks a little bit like this: object gets function, or object is created from function. So you might say, like, object might be model1 gets, and then linear estimation, blah 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 blah. So you're saying I'm going to create an object called model1, and I'm going to create it from or get it with some function like linear estimation, which is a function for doing a simple linear regression. Couple things to note: R is case sensitive, which is frustrating because a lot of times you'll type a command into the command line and you'll think you've got it correct, but you'll get a syntax error. Also, there are different naming conventions for how you name objects, and this varies somewhat. So for instance, people who work a lot with Google or who do programming with Google will use a naming convention with lowercase letters and dots. So you might have an object called child anxiety. That could be like a data set of anxiety measures on a group of children, or it could be some sort of a variable that you created to describe the level of anxiety that children have, or it could be a model where you're predicting anxiety from some other variables, whatever. If you're kind of using the Google naming convention, you could call it child.anxiety. There's another naming convention called associated with the name Wickham. I forget exactly who Wickham is or was, but that's the underscore naming convention. So you like child underscore anxiety. Old school programmers often will use uppercase and lowercase letters to denote different names. The important point here, or two important points I would make here, is as far as I can tell, and from my own experience, R doesn't tolerate spaces. So if you were creating an object called child anxiety, it couldn't be child space anxiety, the way Windows or a lot of programs will allow you to have spaces for names of variables or names of files or whatever. R doesn't. So pick a naming convention that allows you to identify things clearly without using spaces. Be consistent. I think that's always a good idea as well. So if you choose the kind of uppercase lowercase approach, stick with it so that later on when you're looking at objects that you've created, it's fairly clear to you what they are. For what it's worth, I like the old school programming approach. It's just something that I'm sort of familiar with, although again, I myself am not a computer programmer. Now, I've referred to commands already. Commands follow the basic syntax that I described on that previous slide. A command just kind of runs by itself. That's handy if you're working step by step through a series of operations that you're doing with your data, a set of analyses. But what often happens when we do research, or I guess I should say when we do analyses on the data from our research, is we want to start with our raw data, or a set of data that's relatively fiddled with or manipulated, and go through a series of steps that will produce ultimately some graphs and some hypothesis tests and maybe some tables or whatnot. And what is handy to do is to save those commands in a script. So a script is kind of like a program, or it is literally a program. It's a set of commands that can run sequentially, and most people who do data analysis, whether it's in SPSS or SAS or R, as we're talking about right now, like to use scripts because they provide kind of like a record or a diary of the analyses that you did. So if you're working with your major professor and he or she says, how did you produce this graph? Or tell me again how you got this model from this data, you, instead of saying, oh gosh, what did I do first? I think I did this, I did that instead, you can just show them your script. And hopefully if you and if your professor understand your script, understand the commands in your script, you can kind of just look at it and see what you did. There are also ways to mark up or annotate a script so as to leave yourself little notes, like, log transformed the data, removed rank ordered, removed the last case because it was an outlier, ran a t-test, etc., etc. So that later on when you look at your script weeks or months or even years later, it's pretty clear to you what you did. Couple more things about working with R before I wrap it up. R is going to want to make a working directory in your computer. It's a place where it's going to store data, output, etc. The default is probably going to be somewhere in your user directory if you're working in Windows. I'm not exactly sure what it looks like if you're working in Mac or in Linux. You can tell where your working directory is by running the command getwd open and closed parentheses. Here's a little convention that I'm going to try and stick with. When I do my my seminar lectures like this, I'm going to try and use a red highlighter to or red script or font to highlight commands that you could, if you want, yourself run in R just to kind of work along with my lecture. So if you wrote in the command line getwd, it'll tell you what your working directory is. Interestingly, there's also a menu pull down in the console that will do the same thing. So if you don't want to type this command, you can find it in the console. And in fact, if you're just getting started with R and you're working right now with R open on your computer, you can do both just to see how you get the same thing. And indeed, when you use the little console menu, you can see that what R is doing, or the console is doing, is it's writing the command for you and then running it for you. At least a few sources I've read suggest that it's a good habit to create a working directory for each project. So for instance, if you had different research projects going at the same time, which many people do or will do at some point, it's good to put them all in separate working directories. So if you just have, it avoids problems where you create variables that have the same name, or other objects, it wouldn't necessarily have to be variables, create objects that have the same name that then overwrite each other. So the object anxiety for your master's thesis is a data frame of cases and variables about anxiety measures, but then your the object anxiety for your dissertation study is a linear model. And if that's all sort of thrown in a big pile in one working directory, you might accidentally overwrite the one object with the other and not realize it. R can be a little bit unforgiving about that type of thing. So you can set working directory if you want. So that's a command, as you can see in red here, set working directory, open and close parentheses, and within the open and close parentheses, you have to write a colon and then give a path. And so what I'm doing here is I would write out the whole path and then close quotes and then close parentheses to give it a working directory for a directory I'm calling SeminaR stuff. You might have C:/ fill in the path and then write dissertation project or thesis project or so on. again, not that hard to do. The console also has a menu and command for this, so if you don't want to sort of screw around writing your own words on the command line, you can make the console do it for you. It's a little bit easier because then you can browse around the directories and subdirectories on your computer. It makes it a little simpler. But important point here is just when you're working in R, if you're practicing or screwing around, make a working directory for all your screwing around. Or if you're working with R on a project, for your thesis, make a separate working directory. It's a good habit to get into. So I've mentioned a couple times about packages and installing packages. Just again, a package is a collection of functions. They're usually designed around a specific activity. So someone will write a package to do, I don't know, time series analyses for data, or they'll write a package to do I don't know, like rock curves or other item analyses or Bayesian inference in a particular way. So somewhere out there, there are very clever people who are statisticians and they're programmers, or they're working with programmers, and they make packages that allow you to do things, sets of functions that you want to do. Your packages are stored in a library. It's a kind of a directory where R is going to want to put all the packages that it either already has when you initially download it, or that you have subsequently installed. So it's kind of like your place where you're storing all the tools or functions that you will use. R has a default library location. You don't usually have permission to write into this directory. That is one thing that R is kind of protective of. It doesn't want you to actually accidentally screw it up by changing a lot of stuff in that library, because then R as a whole potentially would not function. But if you're curious, you can see where R's library is, and you can actually set up a separate library. If for some reason you wanted to create a separate library for a bunch of packages, you could do, you could look to see where the library is. The function .lib paths open close parentheses will tell you where the library is that is the default, and there's a way to actually change that in the console if you want to set up a different library. A couple things here. Note in the command libpaths, note the period and note the the capitalization where lib is lowercase and for some reason p is uppercase. Now, I don't know why that is, but it's a really good example of something that's often frustrating about R, is that there'll be capitalization conventions that don't seem very consistent. It just is the case that that's how that that's how that command is written. Again, this is probably not something you really need to mess around with, at least not right now. Just allow R to use its default library location. I think the only reason why you might want to set up a different library location is if you were yourself creating packages, if you get to that level of sophistication in programming, or if you were using a package which you had some reason to believe might be kind of unstable or kind of wonky, and you didn't want it to accidentally screw up a bunch of packages that you already work with and that you're comfortable with. I guess you could make a kind of a new working directory for your library. This is not something I think I've ever done, but you could. So you want some packages, you've got a library or libraries if you want. The basic syntax for installing a package is install.packages open parentheses open quotes package.name close, and this will put the package in your library. So for instance, if you wanted the package Rcommander, which is a rather cool and fairly sophisticated graphic user interface, more sophisticated than the default R console, you could do install.packages open Rcommander close, and that will go out to the network, get Rcommander, and install it into your library. Note here that the open and close parentheses is necessary. Also note that packages is always plural, even if you're only installing one package. And again, as I just said, Rcommander is just a package for graphic user interface. Rcommander that is pretty cool and we'll actually use in the future. So you can do that by typing in syntax like that, or if you just go up to the menus in the regular old R console, there's a menu and a pull down for installing packages. It's pretty easy to use. So you can go ahead and type the command yourself, or you can go ahead and use the console menus. Either way is fine. But however you do it, install Rcommander, because that's something that we're going to look at a little bit next time. Any questions so far? Well, if I was doing this lecture live, of course I would take questions live. I'm not, so I'm just going to ask, and if you have questions and you're in my class, you can post them on the discussion board or email them to me. Otherwise, put them in the comment section and I will do my best to respond to them. Preview for next time? Well, we'll talk a little bit about Rcommander, this package, which is itself a GUI or GUI for R. It makes R easier to use. We'll start talking a little bit about graphics and graphing in R using Rcommander. And for those of you who are enrolled in my Psych 440, 640 class, I'm going to open up a content area on Blackboard that's going to have some interesting R-related content, like some notes, some links to some resources online that you can take advantage of if you're interested. So that's all for today. As I say at the end of all these lectures, thanks for your attention. I appreciate it. If you have questions or comments, let me know. Otherwise, take a break, relax, have a cup of coffee, a cup of tea, stimulate your mind, allow some of this stuff to percolate, and hopefully it'll all make sense to you, and you'll be ready to go when I come back with another lecture in my SeminaR series. So thanks very much. Bye-bye.